And so every time he runs across something mathy, he's like, hey, what's the answer? And I'm like, 9. He's like, man. All right. They love pointing out these things in those sort of programming classes. Okay. So some basic ideas. So hopefully you know that. That should be just fine. Pretty good stuff today. Example 1, evaluate each of the algebraic expressions for the given values. Again, when you're taking notes, which you should be doing because I'm going to give you a grade on them, write the directions. Example 1, evaluate. If you want to simplify this, you could say evaluate for the given values. Evaluate for the given values. Example 1. All right. Evaluate the expression for the given values. What's an expression? Something without an equal sign. Very good. Yeah, so an expression is anything connected by operations, addition, subtraction, multiplication, or division. It does not have an equal sign in it. And so this part here is the expression. And so we have values that we want to basically just plug in place of the variables. And so I'm going to do that. And it's important that when you plug those in place of the x, I'm plugging in a -1. And in place of the y, what am I plugging in? -6. So when you plug stuff in, super important that you use parentheses just to make sure when you substitute, use parentheses. That way you don't make any mistakes. It's really good. All right, once you've done the first plug-in step, what do you want to do next? So in our innermost set of parentheses, you'd see right here, I guess I should put it on the bottom. There we go. We can multiply 5 times -6. Is it wrong for me to go ahead and multiply the 2 and the -1 together as well? Could I do that too? Yeah, okay. So just to make life a little bit quicker. 2 times -1 is -2. We got a negative sign. I still have big brackets here. 5 times the -6 is -30. Subtract 4. All right. So we did some little multiplication steps on the inside of our grouping symbols. And then what do you want to do? Inside the parentheses. So we still have some grouping symbols inside. Yeah. So we can do this. -30 and a -4. What is a -30 and a -4? Good. All right. Now what? Is it like distribute? Like, do I need to distribute, or is it really just sort of clean it up? Catherine, what do you have a question? Yeah, really, that's just we got 2 negatives. Negative times negative, really, if you will, becomes positive. So we have -2 plus 34. Very good. And right here, so negative times negative really is just a positive. All right, and then what? Inside the brackets. Very good. So we have 4. And the -2 and 34 is 32. And 4 times 32? I'm going to trust you on that. My math skills aren't so hot. Yes, 128. I concur. Okay. All right, that one. All right, pretty good. Do you have any questions on that one? All right, letter B here. Evaluate when y equals -2. So again, wherever there is a y, we're going to substitute in our value. And so I'm going to do -2, and in place of the y, I'm plugging in a -2. And again, here we have a y value. I'm going to plug in the -2. I could put parentheses, but there's nothing in front of it, so it's not too necessary. All right, what are you guys going to do next? -2 times -2, okay. If you can shorten these steps, I'm totally okay with that. And can I also do this addition in the parentheses there? Okay, so -2 and 4, 2. 4 minus 1, 3. And then we can go ahead and multiply. 2 times 3 is 6 minus 4, and 6 minus 4 is 2. Okay. I'm showing lots of steps. If you can cut that by half, feel free. Okay. It's amazing. Like, I'm excited to teach you guys because hopefully you won't have any trouble with this. But wow, in Algebra 2, this is a problem.
Algebra 2, fractions.
I don't know. I can't remember. Yeah. Oh, we did. We did. Yeah, we did. Yeah, we were reviewing perimeter areas from certain volumes. Actually, all right. Do you have any questions on these? Hopefully, this won't be any problem for you. But I do. Here is something new that you probably maybe haven't seen before. Example 2. Evaluate each of the following if x is a non-zero number. What does that mean, non-zero?
Any number.
Anything but 0, yes. So x is anything but 0. And that's important because if x can be 0, then that we can get a different answer altogether. Sometimes they might say x, if they were using set notation, the variable x such that x does not equal 0. So this is them telling you that x cannot be 0, but it can be any other number. So that's set notation. I don't use it very often. It's fairly antiquated. But if any of you are going to go into mathematics as a field of study, then set notation is used a lot. Okay. This little bar is typically read as such that. It's an abbreviation. If you ever were to like take a dictation course, you'd do such that. Okay. Anyway, so here is the interesting thing. What are these little bars? Absolute value. Very good. Now, the problem here is that when we think about what x could be, we have to consider all the possible numbers on the number line. So we have negative numbers to the left, we've got positive numbers to the right, and we're actually trying to evaluate. What does evaluate mean? I hate the word solve. Everybody always says solve. Evaluate really means find the value, okay? Find a number answer, okay? And so we want to find a value, find a number. So we're actually trying to figure out what number this equals. Well, the problem is when we don't know what x is, and it could be anything negative and anything positive, we might potentially get multiple answers. And this is something we need to think about. So my favorite way to do this, now I am not a rules person. I hate math rules, mostly because I never understood them myself. Maybe you understand rules, and if you understand rules, then go for it, read the rule, it's in your textbook. But when I'm trying to figure something out and I don't know what x is, I like to just plug in numbers, okay? Test values. So that's how I'm going to show you to do this. We're going to go ahead and just test some values of x. And what we want to do is be sure that we test lots of different kinds of values, okay? So we want to make sure that we have an x that's negative and we have an x that's positive, and maybe we want to test a couple of values just so we can be sure. This is an excellent strategy. if you're ever given a problem, like on the ACT, they like to use A's, B's, and C's, and they don't give you any numbers. So plug in some numbers. Pretend X is 2, A is 2, and B is 3, and C is 4. Just plug in numbers and see what happens. It's really kind of interesting. So we're going to test some values. And I really just want to make sure that we get some negative values of X. And, of course, a positive value. Okay. So let's pick a value. Give me a value that's negative. 7, negative 7. Okay, so we're going to pretend X equals negative 7. I want to go ahead, and if X equals negative 7, I'm going to plug it into this expression and see what happens. So I have absolute value of, and what am I putting in place of X? Negative 7. And again, times X, and my X value is negative 7. What happens to these negatives in here? Yeah, it's really just positive 7. So we still have the absolute value of 7 times negative 7. Oh, this is a bad problem. Sorry, well, anyway. The absolute value of 7 comes out as 7, always. And what do we get here? Negative 49. We also want to try testing a positive value. So give me another number.
7.
A positive 7. Okay, so let's pretend X equals positive 7. Same idea. So again, in place of my X's, I'm going to plug in just a positive 7. And evaluate. Yeah, so this one, we still have the absolute value of negative 7 times 7. What is the absolute value of negative 7? 7. It turns positive, and we get positive 49. That's kind of interesting. All right, you can see what happens here. We get sort of different results, right? Okay, so I'm sorry this problem totally blew up in my face. Let's move on to B and see what happens here. I want to do a similar sort of thing. I want to choose some negative value of X and a positive value. All right, give me a different value for X. Well, that's positive value. Give me a different value.
Negative 2.
Oh, I like the 10.2. That's very interesting. Okay, I'm going to do that. We're going to choose X equals 10.2. Give me a negative value. Negative 2. Okay. All right. I'm going to go over here. 10.2. Super fun. Positive value. I'm going to plug in that positive value. In place of both of those X's, what's the absolute value of 10.2? 10.2. And the denominator turns into negative 10.2. And what is 10.2 divided by negative 10.2? Negative 1. Interesting. Okay. Is that going to happen for every positive value that we plug in for X? If you plug in an 11, you would get 11 over negative 11, and the result would be negative 1. If you plugged in a 30, you would get 30 over negative 30, resulting in negative 1. So is that true for all positive values of X? Yes. And so we can sort of summarize this because now, we realize it generalized. Does it work here? No, this is why this blew up in my face. Okay, so bad problem, my fault. So because when you realize they cancel out, it's interesting. If the X value is greater than 0, what do you get? You get negative 1. Is it negative 1 for the other one?
No, it's not. Square root negative x squared.
So let's see what that is. All right, so this is, let's see, I think in your book it might say negative 1 if X is greater than 0. It's another way to say the same thing. But this is sort of conditional, a sort of conditional answer, I would say. So for all positive values of x, and that's what this means when x is greater than 0, all positive values of x, our result is always going to be -1. Okay, kind of interesting. So let's see what happens when we plug in that -2. So in place of x here, I'm going to have the absolute value of -2 over the opposite of -2. Watch it when you plug that in. You're plugging in place of the x. So it's the opposite of your value, which turns to, yes. So my numerator, what is the absolute value of -2? 2. And then the opposite of -2 is 2. And so this is going to reduce to 1. Is that going to happen for all negative values of x? Okay, does that kind of make sense to you? Do you see how that works? And so you can, if you don't get it, try another value and see that you'll get the same thing. It's going to reduce itself away. And so we get an answer equal to 1 if what? If x is less than 0. Very good. All right. Okay. So plugging in numbers is really a great strategy if you're just, I don't know what that's going to be. But when you plug numbers in, it's like, oh, it just sort of makes sense now. Okay. But feel free to read the rule if you would like to. There we go. So you have I think one problem. Well, it's technically 4. The very last thing. Do you have questions for me? Cool. All right.